I said yesterday, like for the first four, you didn't have to list the oblique asymptote for number four. Just say no horizontal asymptote. Okay, for that one. The one I want to really make sure I commented on was number 7. And on your chart for the test, you got to list the minimum number of points. We said between and beyond, x-intercepts and vertical asymptotes. So right here, I have a vertical asymptote at -3. I got an x-intercept at -2. You have to pick -2.5. You've got to plug that in. Even if it's, you can't say there's no number there. Yeah, there is. There's a lot of numbers there. They just all are fractions. So pick -2.5 because you got to determine whether that goes down or whether it hits and goes back up. Okay, you're not going to know for sure unless you actually plug in a point. You got 2.5 and 3, or 2 and 3. You have to pick 2.5. Okay, so for this one, you'd have to have something to the left of 3, so -4, -5, -6, whatever. -2.5, 2.5, and then 4, 5, or 6 to the right there. Okay, so you got to make sure you pick at least the minimum number of points. Okay, all right, flip it over on the back. These next two have, they got a lot going on, so you really got to make sure you understand and plot your points correctly. But, you should have this piece over here on the left. And then I plotted more than necessary. Okay, you didn't need to plot that many, but just trying to match points that you might plot so you would have that as a reference. So it should dip down below. It hits at, what is that, -1/2 right here. It hits at 3, so I need to have a point in between here. I got 2 and -5/16. You're not going to get nice numbers. Like, it's just the way it is anymore. It's like not everything works out to be nice whole numbers. And then you should get oblique asymptote. This slant asymptote should be x plus 6. And if you graph that wrong, then obviously it's going to be very difficult to see what's going on. But that should be, like I said, x plus 6 for that one. X-intercepts at 0, 0. -4, y-intercept would be at 0, 0. Okay, so look at that one. And then there's your two equations from the graphs. Okay, you will see those. You will see a graph. You will have to give me the equation. Okay, for that one. That'll be on the calculator part. I'll give you a little bit more information here in a second. All right, questions? All right, let's take a look at this one here from those guided notes. I don't think you had a chance. I don't think I had you write that down. This is on the back of the guided notes that we did the last 2 days, or you can just look at it. All right. We have not done a specific problem like this, but you got to combine everything you know to solve this. You've got enough information up here. You just got to get it out. So think about it for a second. Think about how we would do this. I'll leave that answer key on your desk here for a little bit longer. If anybody's still looking at a couple things. Maybe. That's pretty generous. Well, let's hope. Ann, any idea what to do?
I factored the numerator and the denominator to start off with to see if anything canceled.
Oh, okay. All right. Anything cancel?
No.
No. All right. And so you can factor, not necessary. Not necessary. Okay, but if you did it, that doesn't hurt anything at this point. All right. We talked about this. Or you can cross a horizontal asymptote. Allowed to do that. So this one does. But we want to find the exact point it hits at. So if you look at, hold on, man. What do we have? So like this hits the x-intercept is the same as it lies on the horizontal asymptote. So that one works. If you look at number 8, it does hit the horizontal asymptote. Okay, so that does happen. All right, Matthew, what were you thinking?
So my idea to solve for the coordinates would be to find the horizontal asymptote for first, and then once you know what that value is, you can plug that in as y and then solve for x to get your x value.
There you go. Couldn't do it any better myself. All right, what's the horizontal asymptote?
1.
1, because they have the same degree. So looking at here, they got the same degree. Take a look at your coefficients. The horizontal asymptote equals 1. That will be the y value. Okay, that'll be the y value. So it's going to cross at 1. We need to find the x value where that happens. So let y or f of x equal 1. And so you got 1 equals x squared plus x minus 2 over x squared minus 2x minus 3. So you get that. Now here, if you did factor, you probably want to multiply them back together. Or just, go with the original one. So just solve this one, multiply both sides by that denominator. Whoops, I didn't mean to do all of that. And so I'm going to multiply by x squared minus 2x minus 3 times x squared minus 2x minus 3. Since those denominators cancel, this ends up working out not too bad, especially since that's a 1. That just gives me x squared minus 2x minus 3 equals x squared plus x minus 2. So now you got an equation. What happens to our x squareds? Cancel, add up to 0. So I subtract x squares on both sides, minus x squared, and then I get negative 2x minus 3 equals x minus 2. So now I got a linear equation. Add 2x. I get negative 3 equals 3x minus 2. Add 2. Negative 1 equals 3x divided by 3. X equals negative 1/3. All right, make sure you answer the question. Just find the coordinates. Okay, find the coordinates. Well, x is negative 1/3. What's my y coordinate? It's got to be 1. So make sure you list that as negative 1/3, 1. All right. I don't know if I call these guided notes, but these are kind of guided notes. Gives a little overview of the chapter, and then we're going to review a couple things while you're finishing up on that out. All right, this just kind of goes through all of chapter 3. All right, quick test review. You got your quadratic functions. You got to complete the square to put quadratic in standard form. I bet you half you're like, I don't even remember what the standard form is. Okay, because it's been a while since we did section 3.1. Remember that is y equals a times x minus h quantity squared plus k, sometimes called vertex form. Okay, so that's that form for a quadratic. Find the range of a quadratic. Get your polynomial functions, degree, and behavior, which we've been doing this over the course, not just in 3.2, but it's in all of this in graphing and that. So it's been hit multiple times. Finding zeros, sketching graphs. So you got to understand multiplicity of 1, multiplicity of 2, multiplicity of 3. 3.3, synthetic division and long division. Okay, but synthetic division just comes up naturally when we're solving for higher degree functions. Real zeros of a polynomial function, You do need to know Descartes' rule of signs. We'll do one like that today. Rational root theorems. That is your B over A. B over A is, whatever, plus or minus 1, plus or minus 2, plus or minus a half, etc. And then those are our possible roots, and we use those to plug in for synthetic division. Complex zeros, okay, that's just problems that end up having an I in an answer. And now what we've been doing for the last few days are rational functions. Okay, finding horizontal, vertical asymptotes, x-intercepts, all that good stuff. Okay. All right, 2-day test, 60 points each day.
So 3-7 will not be on there?
No, because it's on there now. Okay, yeah, we did not cover 3-7. It just is it works out better. I will do that. Actually, that's now section 1-6, but don't worry about that. You don't need to do 3-7. Okay. So you got a no calculator part and a calculator part. Okay, no calculator part. That's where you get the standard form, domain and range of quadratics, end behavior and degree of polynomials, roots of polynomials. Okay, sketch polynomial functions, Descartes' rule of signs, and then graphing rational functions. I will not put oblique asymptotes on that. Okay, so you do not have to worry about that. And where it says solve polynomial rational inequalities, that will be the next section. So don't worry about that. Calculator part, you'll have some true false. Be able to list all possible rational roots, word problems from the quiz. So you want to go look over those. A little bit of name that graph. Write the function given the roots, and then find roots of polynomial where you can use your calculator to find the roots. Okay. All right, let's take a look at a couple. All right, so these are right here. What's the minimum number of times a 6-degree function can hit the x-axis?
6 times?
6 times. Do we agree or disagree? Well, I have no idea.
Maximum or minimum?
You read it as minimum, but it's
Did I
Yeah.
read it as minimum?
Yeah.
We'll go maximum. Maximum is 6 times. Maximum is 6 times. Okay. Of degree n, it can hit it n times. Does it guarantee it'll hit it 6 times? No. What is the minimum? Now I'll say that. What is the minimum number of times a 6-degree function can hit the x-axis?
Twice.
0. Not once, but 0. 0 times. All right, now I want you to think. Why? I want you to think why. Think of what is the simplest 6-degree function? Simplest. X to the 6. Y equals x to the 6. Now, what does that look like? That does hit the x-axis at 0, but what could I do to that equation to make sure it doesn't hit the x-axis?
Add 1.
Add 1. Add any constant. Y equals x to the 6 plus 1. Okay, just shifts it up. So you got a 6-degree function. You don't have to have it, all the terms, just that's a 6-degree function. All right, I want to change this slightly because this ended up being a little bit easier than I thought when I say 2 times. Make it 3. All right, you give me an equation, a 6-degree equation that hits 3 times. Let everybody think a little bit here. You got a question or?
There's a question.
What's your question?
Do you want it to be all factored out, or can it be in factored form?
It would probably be easier if you leave it in factored form. Okay, I would suggest that. So, because if you do this, like if you're sitting here going, well, maybe it's f of x equals 3x to the 6th plus 2x to the 5th minus 4x to the 4th plus 3. You're going to have to graph every one of those. So, I would leave it in factored form. All right, take a second, think about it. hits exactly 3 times. All right, there you go. And once you get it, it's really easy. But until you get it, it's really, really hard. Oh yeah, once you see it, oh yeah, that's
Yeah.
Don't do that.
I want to see what the final answer is.
All right, you can do that, but don't do that on the test. That's a waste of time. All right, Dakota's figured it out. What do you got for an answer?
I have x minus 1 in parentheses squared, x minus 2 in parentheses squared, and x minus 3 in parentheses squared.
Okay, that's all you gotta do. It's gonna hit at 1, 2, and 3, and it's gonna bounce at each one, but it hits it 3 times, right? Can't hit it anywhere else. All you gotta do is give me factors, 3 different factors that whose exponents add up to 6. Okay, that's all you gotta do. And it doesn't have to be 2, 2, and 2. So you might have done, I don't know, 2x times x minus 3 squared times x plus 4 cubed. 3, 2, 1. That's fine. Okay, whatever combination. It's really all you got to do. Okay, for that one. Don't need to multiply it out. Actually, don't multiply it out because then that makes it a lot harder for me. So all you got to do is look at that. All right, let's flip it over then. We're going way back here, section 3.1. So rewrite the following in that vertex or standard form. Remember what we got to do. There's 2 ways you can do it, but I would suggest for this one to complete the square. So I'm going to complete the square on the 3x squared minus 18x. But I have to factor out the 3 first. Okay. Plus. And don't forget to factor out the 3 out of both the 3x squared and the negative 18, not just the first term. All right, now we just go through our procedure. Complete the square. Half of negative 6 is negative 3. What do we want to do that? Square gives me 9. All right, now you got to be careful here. This is where you got to watch. Since that 3 is affecting that 9, it's really 3 times 9, which is 27. What do we got to counter that with? Negative 27, because in this case, it has to add up to 0 because it's on the same side of the equal sign. So we're really not changing it's still going to be worth the original equation if you would multiply everything out. You still got to get 3x squared minus 18x minus 11. But we're just changing its form. And so I got y equals 3 times x minus 3 squared minus 38. All right. What did we ask for? Oh, that's all I asked for. So that would be your form. All right, vertex. And just so that we know, remember your vertex will be positive 3, negative 38. What is the range? Okay, while we're here, just so you have it.
Is it negative 38 to infinity?
It is negative 38 to infinity because 3x squared tells me it opens up. My vertex is 3 negative 38. And so that would be negative 38 to positive infinity. You need that y value. Remember, there is another way to find the vertex from the original form, and that is using the h equals negative b over 2a. You can eventually get to this form that way. I think since it just asked to write it in this form, I would do completing the square, but you could plug that in, and that'd give us what? Minus negative 18 is 18 over 2 times 3. That gives me 3. You plug 3 in to get the negative 38. Okay. But just that does come up the vertex there. All right. Descartes' rule of signs. We want to use that to determine the number of positive. And it's actually not, I need to take that out. It will be the number of positive real zeros and the number of negative real zeros. Okay. It will be that amount. Remember what we're looking for positive? We're looking for variations of sign. So if you're given the function already, we want to take a look at how many times it changes. So negative to positive is 1. Positive to positive doesn't change. Positive to negative is 1. Negative positive is 1. So we got, how do I word our answer then for positive zeros? There will be 3, 4, 1. You always subtract 2. So there are 3, 4, 1 positive zeros. Can't be 2. Can't be 2. Can't be 0. So it's 3 or 1. All right, so for the negatives, this is where we do f of negative x. And that gives me negative 2. Let's see here. Replace x with negative x. Plus 2 times negative x cubed. Plus 7 times negative x squared minus 8 times negative x plus 20. Now remember, it really will only change the sign of which terms. Terms with what type of power, Matthew?
An odd degree.
Only odd degree powers will actually change signs. Because when you take a negative number to an even power, it comes back positive. So I get f of negative x equals negative 2x to the 4th. That will become minus 2x cubed. That will be plus 7x squared plus 8x plus 20. How many variations do we get? 1. So how would we word this? 1, negative 0. 1, negative 0. You can't subtract 2 from that and get a positive number. All right, where Descartes' rule of signs? So you got to have 4 total. So it's either 3 or 1 negative, or it's 1 positive and 1 negative. The connection, why does it skip 2? Has to do with complex roots, because if it has complex roots, they always come in what? Pairs. So there's 2, and a complex root is neither positive or negative. Okay, it's not a positive number or a negative number. So you could have 1 positive 0, 1 negative 0, 2 complex zeros. Or we could have 3 positive zeros and 1 negative 0 and no complex zeros. The only thing this does, it might say, all right, I have a greater chance of having a positive root. I'll just start with the positive numbers. Okay, that's really all it does. And all right, let's take a look at this last one. This would be definitely, you will see something where you have to go through that whole procedure of finding the zeros by using synthetic division. All right, technically, how many zeros do I need to find using synthetic division? For this problem. 1. I just need 1. Why only 1? Because once I get it down to second degree, I can use factoring or quadratic formula. Okay, so you're definitely, because we spent a lot of time on this. So in this case here, my A is just a 1, which is nice. B is 1, 2, 3, and 6. And so B over A are the possible zeros. And since I'm dividing by 1, it's just going to be all the whole numbers. All right, everybody pick 1 and do it with synthetic division. If it doesn't work, then just wait. But pick 1 number, test it. If it's good, pat yourself on the back. If it's not, don't think you're a failure. Hopefully we can get 1. Anybody got it? What you got, Lynn?
-3.
Jordan? -3? -3 is correct. Actually, that's the only one that'll work. So if you didn't get it, go ahead and use synthetic division with -3. Oh, you tried how many? Oh, you were 0 for 5, 0 for 6.
Yeah.
Oh, man, how many are there? 8. Not you're on a bad run there. -3. 1, 1, -8, -6, 0, 1, -3, -2, -2 times -3 is 6, -2, 6, 0. Ooh, let me see something though on all your mistakes. Oh, you finished now? Shoot. See if we had any upper or lower bounds. No, 2 came out being upper bound, so we wouldn't be anything above that. All right, so now we got f of x equals, since -3 is a root, x plus 3 times x squared minus 2x minus 2. And we hope it factors, but this one doesn't. So if it doesn't factor, we got to use what? Quadratic formula. Okay, so we're going to use quadratic formula. And you have to simplify this correctly and reduce it. Okay, so when you're done. So I get A is 1, B is -2, C is -2. So using this, x equals negative, opposite of B is 2, plus or minus. B squared is 4 minus 4 times A times C over 2. I get 2 plus or minus square root of 12 over 2. All right, what's square root of 12 become? 2 square root of 3. So I get 2 plus or minus 2 plus or minus 2 square root of 3 over 2, and that'll simplify it. I do still see some mistakes here. 2 plus or minus 2 square root of 3 over 3. 2's all cancel, so it is left with 1 plus or minus radical 3. So the zeros are -3, 1 plus or minus square root of 3 for that.
What were you saying about the upper bounds and stuff?
Oh, I was just seeing if that won't be on the test.
Okay.
I was just seeing if one of those was an upper bound.
How'd you know?
If you get an upper bound, anybody remember an upper bound? We went over it briefly. If the last row, if the bottom row is all positive numbers or 0, then it's an upper bound. Then we won't get a 0 above that. And if you looked at number 2, when you plugged in 2, you should have got all positive numbers down there.
When I got a negative.
You did for 2? One of those was a negative?
Yeah.
Oh, then I misread it.
3 was all positive.
All right, well, maybe it was 3 then. So 3 would have been an upper bound.
Okay. So if it's a lower bound, it's a negative then, right?
If there's a lower bound, then they alternate signs, positive, negative, positive, negative.
Or negative, positive, negative.
Or negative. That would be the same as alternate. So,
Well, I'm just double checking.
no, that would be the same. All right, page 416. Work on this. The rest of the period. This does not have to be submitted, but you do need to work on it the rest of the period. You may work with somebody, it's fine. I'll put the answers up. I'll have them up for the even ones, just so if you want to double check. I want to collect the answer key to worksheet 36 here in a minute. Now for 21 and 23, 21 through 23, it says just sketch. If you look at the directions give you like 5 different things you need to do. Just sketch. And if like the roots are -1 and 0 and 1, make sure it's wide enough on the x-axis so it's clearly what's going on. You can spread out your work. It's not a big deal. All right. Yep. All right. Get through whatever you got questions on that, and I'll do it.
had it, and then it was so good that like the people were laughing, so it wasn't even worth it. I'll make it worth this weekend. I just didn't have time.
Well, I got extra. I just gotta make some.
Really, because
You can come to me if you want.
I have an empty soup box tomorrow.
You what?
Oh, and then go there.
I'm trying to
He's trying to bribe me to come over there.
come over there.
The answers.
You just need help getting the answers. Is that what it is?
Do I need to go back and delete your name and then search the English content?
Can make academic dishonesty to me.
I gotta do it.
Oh.
Guys, I was doing this.
I don't know.
Okay, no, your losses.